Welcome to a new video by Geosystems. Today I want to show you how you can atmospherically correct satellite images by using the ATCOR Workflow for Imagine with the ERDAS IMAGINE Spatial Modeler. Maybe you have already seen the other movie, How to Use the ATCOR Workflow for Imagine on the basis of the dialogue. In this example, a Sentinel-2 multispectral image of San Francisco will at first be dehazed and thereafter atmospherically corrected with ATCOR 2. Additionally, a haze map with different classes will be created. In comparison to the dialog option, here the whole workflow is automatically processed all at once. Thus, it is very efficient. It is optimized as the two processes of dehaze and ATCOR 2 are done in one go. Oh, by the way, this satellite data has been simply downloaded by using the Sentinel-made simple downloader of Geosystems. A short info how the Sentinel data is organized. Here in my folder, you can see the Save directory. Save is the ESA-specific format for their data. Today I'm interested in a granule 10 SEG, which shows the area of San Francisco. Generally, Sentinel-2 satellite images are provided as JPEG 2000 files, with one file for each band. In this folder you find the granules in which the JPEG 2000 images are stored. Okay, let's get this on. I create two folders, which I name ATCOR Project and ATCOR_output. First of all, I want to show you the scene we are going to atmospherically correct. We can see that there is a lot of haze in the image. Here it makes sense to previously, in a first step, use the ATCOR dehaze. I navigate to the tab toolbox and select Spatial Model Editor to open the Spatial Modeler view. From the Operators window here on the right, I open the group Geosystems ATCOR. You can see several operators for the ATCOR workflow. To dehaze our scene, I have to select the according operators and connect them. Thus, first I have to create the project and select the operator Create ATCOR Project. I connect this with the next operator Run ATCOR dehaze. In comparison to the approach using ATCOR for Imagine dialog, here I can extend the spatial model with the next step, the ATCOR 2. Therefore, I select to set Atcore Parameters and run ATCOR 2. With the ATCOR Workflow dialog, the dehaze and ATCOR 2 are splitted in two parts, where I have to start the second part manually after the first one has finished. The spatial model for ATCOR enables me to select the processing parameters for both processes at once and get the two parts processed in one single workflow. Thus, hands-free in the meanwhile for other duties. Then I connect the operators with each other. The Create ATCOR Project, it creates a new project which I connect with the input port, ATCOR Project In, of the Run ATCOR dehaze. This executes the dehazing. Its project out, I do connect with the project in of the set Atcore Parameters operator. Its parameters, relevant for ATCOR 2, I set at last and connect the output port with the input port Run ATCOR 2 operator. This executes the atmospherical correction. For the first operator, Create ATCOR Project, I select by double-clicking on the port ATCOR Project folder my created project folder. For the Imagine file name, again, double-click, select the metadata file in the XML format. Thus, I move to the granule folder and select my 10 SEG granule. There is the XML metadata file. This is Sentinel specific. Next, I open the port sensor and select Sentinel-2, 13 bands in a drop-down and click OK. Now, for the second operator, the Run ATCOR dehaze. Different ports have to be set. For the dehaze method, I change it to Auto. For the dehaze area, I select Land and Water Pixels. The dehazed image name shall be in the output folder. I type in the acquisition date, which is 2015-11-17, and underscore dehaze. The third operator is the set ATCOR Parameters. Here I do have to enable some ports in the properties on the right. Water vapor category, aerosol type, and value-added products. They appear at my operator and I select for the water vapor category US Standard, for the aerosol type Auto, and for value-added prods, I check the mark and thus change to True. The fourth and last operator is the Run Atcore 2. For the corrected image name, I select my output folder and name it 2015-11-17 and underscore Atcore 2. The atmospheric correction Atcore 2 is executed on a dehazed image. Do not forget to save the spatial model. Therefore, I go to File, Save As, and save spatial model as 2015-11-17 underscore create underscore dehaze underscore Atcore 2 into my project folder. Now the spatial model is ready to run. Therefore, I go to the Spatial Modeler tab and click on Run. An advert window pops up as we are in the free license mode of IDL. Just click on it. Depending on the power of your machine, the processing will take some minutes. While an Atcore project based on a Sentinel-2 dataset is created, the following tasks are executed. It reads out the information from the metadata file, which comes in the XML format. It compiles a layer stack, either with 13 bands at 20 megapixel size or with 4 bands at 10 megapixel size. This depends on the sensor you specify. In this case, the 13 bands on 20 meters. Important to mention at this point, the created project can be used for all three Atcore processes: dehazing, Atcore 2, and Atcore 3. We see the process has finished successfully. The spatial model ran through. We also see a warning icon at the Run Atcore Dehaze operator and an info icon at the Run Atcore 2 operator. Let's see what the Spatial Modeler messages window tells about these icons. I go to the View box and open the messages. The first entry is the warning for the dehaze process. No elevation file available. Dehazing without elevation file. This tells us that yes, we did not use a DEM. Well, we could do, but this is optional. The other entry is an information for the Atcore 2 process. The message let us know that the atmospheric correction has been executed on the basis of the dehazing result. This is done. Now I want to show you the result of the Atcore dehaze. First, I go to the project folder. There I find a created folder named TOA Reflectance. Here is the layer stack which the program created from the original bands. I fit the layer to the window size and quickly have a look into the image metadata. You can see this is a layer stack of 13 bands with a spatial resolution of 20 meters. I take this original image to compare it now with the result of the dehaze process. Thus, secondly, I go to the output folder and select the dehazed image. You might already see a strong change. Let's compare. Therefore, I switch the swipe tool on. Have a look on the difference by yourself. I close the transition to load the haze map by dragging it into Imagine. Well, I will use the swipe tool once again. I want you to focus on this nice haze South San Francisco indicated with the arrow. We see that the ATCOR Workflow calculated a map with different categories. Let's have a look into the attribute table. Here in blue is the class over water. Atcore detected clearly haze. The haze map category changes over land and overall the haze is easily detectable with the eye. Let's have a look into the project folder. This Geosystems Atcore project file Never rename it. Next, I want to show you the calibration file in the text editor. It contains the sensor and image-specific calibration parameters. As for Sentinel-2 data, a metadata import is provided. The calibration file will be prepared and written to the project folder. Finally, let us examine the log in a text editor. It contains detailed information about the executed process, such as the scene average global flux, reflectances, but also warnings and error messages. Just have a look by yourself. Also pretty important and informative, the Imagine session log. To access it, in Imagine go to File, Session, and open the log via the View Session Log button. It lists the single steps which have taken place or which actually happen live, if you keep this window open during processing. Well, I kept you waiting long enough about the result of ATCOR 2. I am also curious. Let us have a look at the result. Now you can see the San Francisco scene atmospherically corrected. I will use the swipe tool another time. Now, using the Inquire cursor, I can compare the result of the atmospherically corrected image with the original image. The corrected image provides a surface reflectance spectra. You can easily calculate the surface reflectance in % by dividing the pixel value by 100. This is the applied reflectance scale factor, which we previously have set for the advanced settings. Now I will examine the spectral profiles. Therefore, I select the Golden Gate part. It might be suitable for this purpose. The first profile is for the original uncorrected image. Thus, no dehaze nor atmospherical correction has taken place. I zoom further in and will pick the sports field. For the spectral profile tool, always the lowest layer is considered. This is why I moved them in the table of contents. I will compare this with the dehazed and ATCOR 2 corrected image. The differences for the same spot are clearly to identify. Finally, what I do not want to keep from you is the value added products file. Let's have a look at it. I go to File, go to Open, and select Raster as Image Chain. I select from the output the ATCOR-2 _ FLX image file. Move to Image Chain and select Pseudocolor. I select the first layer and the NDVI natural in the color table. The first layer is my soil adjusted vegetation index, SAVI. In this video, you have learned how to use the ATCOR workflow for Imagine to dehaze and atmospherically correct the multispectral Sentinel-2 image with the Spatial Modeler. Thank you for watching. I hope this was helpful. For further information, visit our homepage geosystems.de.